In this lesson, I will tell you about iRidium native drivers in general, that is, what types of native drivers iRidium has, how to set them up, and how to use them in your projects. So let's start with the main storage of native drivers. It's the Device-Based tab of iRidium GUI editor. Here you can see a drop-down list of databases where all drivers and databases are kept, and they are all included in the main database. Native drivers are kept in iRidium base version 2. The Supported Controllers tab contains all drivers included in iRidium core. Here you can see AMX, Avian Custom System, BTC-No, Clipsal, Crystron, Domintel, Dua Techno, an AppSnare driver for working with in-house equipment, Teco, AGL S Pro, Canex, Lutron, Modbus drivers. In the future, other native drivers will be also added here. Let's describe adding of iRidium native driver to your project. Let's take the driver for working with Canex equipment. For adding the driver from iRidium base to your project, you should use the drag and drop method. Just drag a necessary driver to the project device tree and drop it any place of the project device tree. As you can see, there is a new device, Canex Router, in the Drivers tab, and if we select it in the Properties tab, we'll see all properties of this driver. Its properties are device name. Two drivers of one project can't have the same name, that's why you have to give to the first Canex router one name and to the other another name. Then we set up IP address. We need it for connection with the device. Then we set up specific properties which can differ depending on the equipment type. But you should not forget that IP address and port must be always set up when working via TCP and UDP protocols. Now we can pass to driver tabs and their description. They are the same for all types of drivers and includes the following settings. The driver token tab. It includes all global variables which contains properties of the controlled equipment. These variables are available for reading only and include the current status of the controlled system which iRidium connects to. So let's start with token online. It's a token which shows the status of connection to the controlled system if the driver is online or offline. There are 4 possible states of connection: offline, online, connect, and disconnect. The next property, host. It contains the domain name of the remote system which we set up the connection to. It's important if you use DNDS. IP is an address of the control panel connected to the remote system, that is a client IP address where the driver and iRidium project are launched. Port is a local client port used for connection with the remote system. It's a port on the client. Host IP is an address of the remote system which connection is set up to. So host port is a port of the remote system we are connecting to. Thus, with the help of these tokens, you can output the status of connection to the driver you are working with in the project. It's very convenient for monitoring the connection state. If you want to use driver tokens, you should create a graphic item and then drag the token you need on it. For example, a token which contains IP address, which is used for connection to the Canex driver. When dragging, you will see a dialog window where you have to indicate the way of data recording from token on the graphic item. If you need to output the current IP address according to the value, you have to select in text event. Tokens online and status can be used with buttons which have several states, so-called multi-state buttons. Tag online can be output by the in-value event, that is to affect the current state of the graphic item, and that the graphic item should have 2 states and the channel feedback. Next tab, commands. Here control actions which will be sent later to equipment are formed. There can be lots of commands to the equipment. Every command contains an instruction which must be executed by the control device. To use a command in your project, you have to drag it on a graphic item by using the drag and drop method. And while dragging the command, a dialog window opens. It includes different types of command assigning, for example, send string, sending a string in the ASCII format, send number, sending of the decimal value of the variable, send token, sending the value defined by the graphic item. Send token is always used while working with levels, trigger buttons, up-down buttons. I told you about them in the previous lessons. For example, let's assign a command using send token. That means we are working with trigger button or up-down button or level. A dialog window is open, and here all settings of command sending are indicated. The first setting, an event which affects the outgoing value. In 90%, it stays by default. The second event, it's an event of command sending. That is, press on button, release the button, hold or move, which is used only for level. Here you can also see a dialog for creating a feedback channel. Feedback channel is a variable which is responsible for receiving, processing and outputting data received from the equipment on the graphic item. If you select this option in the project device tree, the feedback channel with the same properties as command setup before will be created. It's convenient when you need to record data from the graphic item to the variable and then read it for showing the actual status of the variable. In value and in text are events of assigning the variable. That means if the variable affects the current state of the graphic item or it outputs data received from the equipment in the text field of the item. The way of signing depends on the properties of the graphic item you want to receive. So let's pass over to the Feedback tab. It contains all variables which receive data from the control equipment. To create feedback, you should use the Create Feedbacks command. Feedback channels will be created on the basis of the existing commands, or you can create the channels manually using buttons in the toolbox. When you drag a feedback on the graphic item, the dialog window will open. It's similar to the driver tokens dialog. Here you select if feedback affects item state or records its value in the text field of the item. So let's make a conclusion. Connection to control equipment is set up in the Properties tab with a selected driver in the Project Device tree. Properties of connection to the driver can be read and output on the interface items with the help of tokens, which you can find in the Driver Tokens tab. All commands to the equipment are stored in the Commands tab. All feedback channels are kept in the Feedbacks tab. Channels, commands, and driver tokens are assigned to graphic items by the drag and drop method. Besides manual creation of commands for controlling equipment, you can also use the functions of import and network scanning. They are available in the iRidium GUI editor. Import enables you to import group addresses from ETS projects, import joins from Crestron projects, and import devices with all commands and channels from iRidium projects which are stored in the IRP or IRPZ formats. Also, import of the files in the CSV format for KNX equipment is supported. Scanning of network will enable you to add all HLAS Pro, Lutron, and Duo Techno devices to the project device tree. If at the moment these devices are in the same local net as in the editor, launch on your computer. When starting scanning network of the iRidium, sends requests and forms the list of available equipment. In this list, you can select devices you want to see in your projects. Thus, there are 3 ways of creating control commands. They are creating command manually, importing commands from files if they are supported to your equipment, and scanning the local network. You can read about the ways of adding commands to particular types of equipment on our wiki. You will learn more about working with particular drivers and equipment in our next lessons. Thank you for your attention.